This video is going to cover section 5.8, modeling using variation. We're going to look at a few different types of variation: direct variation, inverse variation, joint variation, and then also look at like combining them. So variation is just another way to write an equation. So it's kind of a specific type of equation. So direct variation, is one of those specific things. Okay, right here. So if we have two quantities and we call one x and one y, we might say y varies directly as x, or y is directly proportional to x. These mean the same thing. If y is equal to some number times x. So we call that number k, and it's some specific number. And so k kind of just depends on the situation. Maybe it's the price per gallon of gas, and so x is how many gallons we purchase, and y is how much it costs, like the total cost. Then y is directly proportional, or varies directly as x, and the k value would be the current price per gallon. So there's all kinds of things, you could think of for this example. One other thing. So you can have direct variation where it's not just a plain, say, x. Maybe you have something like y equals kx squared. For example, well, no, that's not a good one. I was going to say e equals mc squared, but the c squared is actually the constant. So never mind, that's not a good one. Okay. But basically anything, if you have y equals to some number times something to do with x to a power, maybe square root of x, something like that. And then, of course, to make things more complicated, we can have different letters. Instead of x and y, we could have, I don't know, p and q or something like that. So let's do example 1, though, and just see how this goes. All right, Marla is a realtor. She earns a commission on every property she sells. In other words, Marla's income y varies directly with her total sales x. Suppose she earns $2,250 from selling 1 acre of land at $75,000. Write a formula relating y to x. Use your formula to find how much Marla earns from selling a house for $299,000. So it says y varies directly with x. So that means that our initial kind of bare bones formula or equation is y equals kx. And we don't yet know k, but we do know that when her sales, x is 2,250, and, oh crap, no, that's not it, is it? That's the, goodness, that's the y. Y is what she earns. So her sales, I apologize, her sales would be 75,000. So x is 75,000. So we can just plug these into our little formula template and figure out what k is. So 2250 is equal to k times 75,000. So to figure out our k, we can divide both sides by 75,000. And it's going to be something small, so you might even think of it as a percentage. You might already know kind of the standard commission that realtors make. Okay, let me move this guy down here a little bit. 2250 divided by 0.03. So 0.03 is equal to K, or you could think of that as 3%. All right, so now our formula is going to be, we now know y equals 0.03x. And so to figure out her earnings or income from selling a house for $299,000, we can plug into that formula. So y equals 0.03 times 299,000. I've already got 0.03 in my calculator, so times 299,000. Okay, 8,970. So there we go. All right, so let's look at inverse variation. So inverse variation is a little different. So now we're going to have our x in the denominator. So if y varies indirectly or is inversely proportional to x, then y is equal to some number, k, divided by x. And so this is when you have like an inverse relation, well, clearly an inverse relationship, but like maybe if your x goes up, then your y goes down, and vice versa. With a direct variation relationship, both quantities move in the same direction, sort of. So Marla, the more she sells, the more income she gets. As one quantity increases, the other increases, and vice versa. So with inverse variation or indirect variation, it's the opposite. Okay, so example 2, your monthly heating bill probably varies inversely as the average outside temperature. So if you think about it, as the temperature goes down, your heating bill is going to go up, and vice versa. Suppose the average temperature during the month of December is 5 degrees Celsius, and your heating bill for December is $180. Find a formula relating the amount of your heating bill H to the average outside temperature T. Use your formula to calculate your heating bill if the average temperature that month is 7 degrees Celsius. So I'm not really giving y'all time to read these more than once. And it's probably a good idea to pause the video and do that. In general, you're going to want to read any word problem at least a couple of times. Okay, so it said varies inversely. And heating bill, we're going to call H. And it varies inversely, so equals K over the temperature, T. All right. So then we were told that when T is 5 degrees Celsius, our heating bill H is $180. So let's figure out what this K is. So H, $180, is equal to K divided by 5. So to find K, we just multiply both sides by 5. So I think it's $900. Yeah, I'm pretty sure that's right. 900 is equal to K. So then our formula is, oh, yeah, that's right. Sorry. Our formula is H equals 900 divided by T. All right. And then we're supposed to use that to find our bill if the temperature was 7 degrees Celsius. So H equals 900 divided by 7, which I probably should have told us what to round to. I guess let's just round to the nearest whole number. So round to whole number, or the ones place, I guess. Okay. Oop. So $129, about $129. which makes sense since it was a little warmer that month. All right, so those are kind of the two major types of variation, direct and inverse. And for direct, it's y equals kx, so you're multiplying. And for inverse, it's y equals k divided by x. All right, so let's look at a few more examples. So there's another type, at least another type that has a name, and it's called joint variation. So joint variation is kind of another way of saying direct variation, but it's when you have more than one independent variable. So more than one, instead of x, there's multiple x's, I guess, multiple variables over there on the right side of the equal sign. So if we have y varies jointly as x and z, or y is jointly proportional to x and z, it's kind of like, well, I think it is, not kind of, like saying that y is directly proportional to both x and z, or y varies directly as both x and z. And so this is our template for our formula, y equals k times x times z. So notice everything's still being multiplied. So let's just play around with writing the kind of template for the formula because things can get a little bit weird. And then we'll do another, let's see what I've got here. Example 4. Oh, that's it. Okay. So we'll do one other example with a word problem as well. Okay. Write a variation model using k as the constant of variation. Part A, z varies inversely as the cube of x. So z varies inversely. That means we're going to have z equals k divided by something. But it's the cube of x. So the cube of x would be, of course, x cubed. Okay. Part B. T varies directly as W and inversely as Q. So this is perfectly possible that you can have combined variation. So T equals, okay, it varies directly as W and inversely as Q. So there's multiple ways to write this. What I would do is just kind of throw the K in front, and then times anything that's direct goes in the top of the fraction, and anything inverse goes in the bottom. But you could also maybe write it like this: T equals KW, all in the numerator, and Q in the denominator. There's other things you could do, but those are probably the two main ones. Okay, part C. The rat's speed, S, through the maze varies jointly as his hunger, H, and the size of the cheese, C, at the end. Okay, so rat's speed, S, varies jointly as, so equals K. And so varies jointly means everything else, we're just multiplying it. So the H and the C. So it's just going to be times H times C. Now how does the rat know how big the cheese is? Anyway. Okay, so there we go. Part D. And you might pause these and see if you can, try it and see if you get the same thing. So a circle's area A varies directly as the square of its radius R. So A varies directly. A equals K, and then as the square of R, so R squared. And if you know what the area of a circle is, then you know what K is. A equals pi R squared. So actually K would be pi. All right, a couple more. The electrical resistance R of a wire varies directly as its length L and inversely as the square of its diameter D. So if you ever have to take physics, particularly, it's usually second semester physics, then you'll learn about electricity. So resistance is an important part of that. So the resistance that a current encounters as it's traveling along a path. So the resistance R equals, okay, varies directly as the length and inversely as the square of the diameter. So K. And then, so I would write it like this, and then the L goes on the top because that's directly, and then D squared goes on the bottom because that's the inversely. But you could just put the K up there with the L if you wanted to. Okay, last one. Capital Z varies jointly as X and Y and inversely as the square root of P. So capital Z equals K, and then X and Y. So jointly isn't just another way to say directly, right? We like to have multiple ways to say things in math. And then square root of P is inversely, so that goes in the bottom. Okay, last example. Example 4. The kinetic energy, capital K, of a moving object varies jointly with its mass m and the square of its velocity v. If an object weighing 40 kilograms with a velocity of 15 meters per second has a kinetic energy of 1,000 joules, find the kinetic energy if the velocity is increased to 20 meters per second. So pause the video and read this carefully at least one more time. So notice we have this word, varies. That's our key word. And jointly as well, but varies is the kind of the one that you would zoom in on first, I think. That tells you how to solve the problem. So super important to be able to recognize this as a key phrase and then to know what to do with it. So the first thing we're going to do is come up with our template, our formula template based on what varies jointly with what. So, and it looks like we're going to have multiple Ks. That's a little bit confusing. Well, we'll just go with it. I don't like it. Oh, okay. Let's do this. So for our constant of variation, let's use a C for constant. We don't have any C's in this problem, do we? No. Okay. So that's going to be what we usually call K, but since we've already got a K for kinetic energy, constant of variation. All right, so then capital K, our kinetic energy, varies jointly as, okay, normally we'd have a K here, but let's make it C. The mass m and the square of the velocity v, so mv squared. Okay. Now we've got an object weighing 40 kilograms, so that would be mass, and velocity of 15 meters per second, has a kinetic energy of 1,000 joules. All right, so then let's put everything into our template so we can solve for our constant of variation. 1,000 is equal to C times 40 times 15 squared. So if we multiply all this stuff out over here on the right, 15 squared is 225. And then times 40, 9,000. So C times 9,000, I'm just going to go ahead and write 9,000 C. So if we divide both sides by 9,000, we're going to get that C is 1/9. And you could certainly write that as a decimal. You want to write a whole bunch of decimal places, though, to make sure that you don't have a rounding error for your final answer. So I think it's 0.2 repeating. It's something like that. Is that right? I don't know. I think that's right. Okay. Let's see. So now we're supposed to find the kinetic energy if the velocity is increased to 20 meters per second. All right. So if we increase the velocity to 20 meters per second, well, let's see. So I didn't write down. We had a template, so now we know the actual formula. K equals 1/9 times the mass times the v squared. And now we're increasing velocity to 20 instead of being 15. So we're still going to use the same m, the same mass. It's just going faster. So let's put that stuff in, and then we're going to find our kinetic energy. So K equals 1/9 times 40 times 20 squared. Okay, so you can put it all in your calculator in one go. This little Windows calculator is kind of annoying, so I'm just going to sort of like do parts of it in my head. 20 squared is 400. 2 squared is 4, and you have 2 zeros. So 400 times 40. And then divided by 9 is the same as multiplying by 1/9. And did I tell us what to round to? No, of course not. So let's round to the tenths place. So this is approximately 1,777.8 joules, which hopefully that seems reasonable because we increased the speed, and so that should increase the energy of this object. All right, so that's it. So in general, with these word problems, you see something about varies whatever in this big word problem. First thing you do is write your formula sort of template. So the K equals CMV squared, whatever. And then you find your constant of variation. So they should give you kind of an instance of all the different quantities that you can plug into your template so that you can find that constant. And then you rewrite your formula with the constant that you found, and then basically answer the last question. So, you know, they'll tell you a couple of the quantities or something, and then you find what the other quantity is.